All right, we're going to take a quick look at questions number 2 and 3 with the parallelograms practice set. This was the first practice set we did for parallelograms this week. Question number 2 here, it says that the measure of DE is x plus 2, and we can see that that is this line segment right here in green, DE, and its measure is x plus 2. And it also tells us that we are looking this time to find the measure of BC, which is a different line segment. It's not a part of a diagonal. Instead, it's the top horizontal line segment, BC. All right, to answer this question, you have to know one of the properties of parallelograms. Opposite sides are congruent, so this means that 3x minus 2, this BC line segment, is congruent to AD, which is this line segment across from or opposite BC. So that means that we can set up a little equation. 3x minus 2 is equal to x plus 4. And if we solve this equation, we can subtract x from both sides of the equation. This gives us 2x equals, we'll add 2 to both sides, 2x equals 6, or x equals 3. From there, we can solve for the actual measurement of BC. Since BC is 3x minus 2, we'll substitute in, right here, a 3. For x, so this will be 3 times 3, which is 9, and 9 minus 2 makes 7. So the measure of BC is 7. In question number 3, we're told the same information. We're told that DE is x plus 2, so again that's half of this diagonal. And then we're told this time that we need to find the measure of line segment BD, which is the entire diagonal. Once again, we're going to use one of our properties of parallelograms, and that is that diagonals bisect one another. What this means is that line segment from B to E, that's not labeled on this one, the line segment from B to E is congruent to the line segment from E to D. That means that we've got x plus 2 and x plus 2 for the upper portion. In other words, since the diagonals dissect one another, we've got 2 times DE, and DE in this case is the x plus 2. So I'm going to replace that using a little bit of algebra. I've got 2 times x plus 2. We know from the previous question, question number 2, that x is equal to 3, and so I'll replace x with 3 here. So this is really just 2 times 5, which is 10, and that's going to be the measurement of the entire line segment. Another way that I could have done this is if I knew that these two line segments were congruent, these two halves of the diagonal, I could have just replaced x equals 3 here, and that's 3 plus 2, which is 5. And that means that the other line segment is 5 as well, so you could have looked at it by labeling the figure. Either way, the entire line segment BD is still equal to 10.